LangGraph's channel-based communication model enables conditional data propagation through selective write operations, leveraging channel write entry to filter updates dynamically. This artifact demonstrates how a Pregel application can conditionally transform and forward values while skipping updates when specific criteria aren't met. We're about to examine a minimal Pregel setup where a single node processes string inputs, conditionally doubling short strings and suppressing updates for longer ones, all while maintaining channel integrity through ephemeral storage. The configuration will reveal how skip none in channel write entry governs update behavior during the execution phase.
From LangGraph, channels import ephemeral value. From LangGraph, Pregel import Pregel node builder channel write entry. Example node. Node builder. Subscribe only value. $lambda x plus x if links 10 else none. Write to channel write enter channel equals value. Skip none equals true. App equals Pregel. Nodes equals example node. Example node. Channels equals value, ephemeral value ester. Input channels equals value. Output channels equals value. App invoke value.
This example demonstrates conditional channel writes in LangGraph's Pregel framework, where a node selectively updates a channel based on runtime conditions. The example node uses a lambda to process input from the value channel, doubling the string if its length is less than 10, otherwise returning none. The critical design choice is the channel write entry configuration with skip none equals true, which prevents none values from being written to the channel. This pattern is particularly useful for implementing guard clauses in data processing pipelines, where you want to conditionally propagate updates without creating null or invalid states. The Pregel runtime manages this as part of its bulk synchronous parallel model, where channel updates are batched and applied between execution steps. By using ephemeral value ester for the channel type, the framework ensures type safety while allowing transient values that don't persist beyond the graph execution. This approach trades off some computational overhead from the conditional check for cleaner control flow, avoiding unnecessary channel updates that could trigger downstream processing. The pattern is especially valuable in iterative algorithms where you want to halt propagation once certain conditions are met, without explicitly terminating the graph execution. The design reflects LangGraph's emphasis on declarative channel management, where write behavior is configured rather than imperatively controlled. This contrasts with alternatives like explicit conditional statements in the node logic or separate termination channels, offering a more composable solution. The skip none parameter essentially implements a filter at the channel write level, which is more efficient than processing null values downstream. For production use, this pattern helps maintain clean channel states and reduces unnecessary computation in multi-step Pregel applications. Let's break it down.
From LangGraph, channels import ephemeral value.
Imports the ephemeral value class from the LangGraph channels module, which provides functionality for creating temporary or short-lived values in LangGraph's channel system.
From LangGraph, Pregel import Pregel node builder channel write entry.
Imports 3 core LangGraph components: Pregel for managing graph execution, node builder for constructing graph nodes, and channel write entry for handling channel write operations.
Node builder
creates a new instance of node builder, which is a utility class for constructing nodes in a LangGraph application. This is the starting point for defining a node's configuration, channels, and behavior before it's added to the graph.
Subscribe only value
configures the channel to only accept subscription updates for the value field, ignoring any other potential fields or metadata in the channel updates. This restricts the channel's update mechanism to exclusively process and store values under the value key, effectively filtering out all other data from incoming updates.
Lambda x plus x if links 10 else none.
Applies a lambda function that concatenates the input x with itself if its length is less than 10, otherwise returns none. This operation is chained via do, suggesting it processes data in a pipeline or stream, transforming values conditionally based on their length. The output depends entirely on the input's length at execution time.
Write to channel write enter channel equals value. Skip none equals true.
Writes data to a channel named value while skipping any none values in the process. The channel write entry specifies the target channel and enables the skip none flag to filter out null entries during the write operation.
App equals Pregel.
Creates a Pregel instance that will manage the runtime execution of a LangGraph application. This instance will coordinate actors and channels, organizing their execution into steps following the bulk synchronous parallel model. The variable app now holds this runtime manager, ready to be configured with specific actors and channels.
Nodes equals example node. Example node.
Defines a dictionary entry mapping the key example node to the value stored in the variable example node. This creates a node registration where the string identifier example node will reference the example node object within the graph's node collection.
Value, ephemeral value ester.
Creates an ephemeral value of type string. The ephemeral value wrapper indicates this value is temporary and won't persist across execution steps in the LangGraph runtime. The string type constraint ensures only string data can be stored in this ephemeral container.
Input channels equals value.
Specifies that the channel will accept input from a single source named value. This parameter defines the input channel configuration for a LangGraph component, indicating it expects data to arrive through a channel identified as value. The line is part of a larger channel definition, where this sets up the communication pathway for data ingestion.
Output channels equals value.
Specifies that the channel will output data under the key value. This parameter defines the name of the output channel where the processed data will be stored, making it accessible to other actors in the LangGraph application.
App invoke value.
Invokes the LangGraph application with a single input containing the key value set to This triggers the graph execution with the provided input data, following the Pregel runtime's bulk synchronous parallel processing model. This example showcases LangGraph's declarative approach to conditional data flow using channel writes. The node processes input strings, doubling short ones while returning none for longer strings. The key insight is how skip none equals true in channel write entry filters out null values at the channel level, preventing unnecessary updates. This pattern creates a guard clause that halts propagation when conditions aren't met, all while maintaining type safety through ephemeral value ester. The design trades minor computational overhead for cleaner control flow, avoiding downstream processing of invalid states. By configuring write behavior rather than using imperative checks, the solution remains composable and efficient within Pregel's bulk synchronous parallel model.
The node doubles the string, but the channel swallows it whole before the next step.